Welcome to this proof of grade 12 geometry theorem. Equiangular triangles are similar. Today we're taking this from question 10 of Eastern Cape, September 22. So 2022. So you will know that it's from an actual past paper, and this is a good way of what to expect in the exam. So we have a triangle ABC and DEF, where they give us A equal to D, B equal to E, and C equal to F. And we have to prove the theorem that states two triangles are equiangular, then their side time proportion. Now, the story we're going to use, or the framework, will be, first of all, we'll do some constructions to replicate triangle DEF here in triangle ABC. Then we will do congruency, where we will prove these two triangles congruence, and then from that will flow that some of the angles are equal, which means lines will be parallel, and then we can use the proportionality theorem. Okay, so that's a rough framework of how we will prove this, and you can think of it as well when you do your actual proof without remembering it off by heart. Just understand. So the first thing that's always important with a proof is to have a construction. Okay. So in this case, we will replicate the sides of DE on this triangle AB. So we will say, let's take this side length and put it over this way, and take this side length and put it over this way. And in real life, you would use a compass, but we're just gonna state what we're doing. And now we're gonna add points. So I'm just gonna call this point R and point S. Okay, so we're gonna prove triangle AR is congruent to triangle DEF, which will give us equiangles. So let's start now with the actual congruency. So in triangle ARS and triangle DEF, we have AR equal to DE, and that's obviously due to constructions. And we have angle A equal to angle D, which is given. And then finally, we have RS equal to, or let's make it AR, sorry. AR, no, we've got AR. So AS equal to EF, and that's also due to construction. Okay, so we have our AS equal to DF, and then we have congruency. So the triangle ARS is congruent to triangle DEF, and the reason is side, angle, side. Okay, and then we can use the congruency. So therefore we say angle RS is equal to angle E. Okay, so let's just put that into our picture. So we say that angle is now actually equal to angle E. Okay, but we know that angle B is equal to angle E. Okay, and that's obviously given. So therefore we know angle ARS is equal to angle B. Okay, and this is due to congruency. So we can therefore say, therefore, we have parallel lines, and the parallel lines will be RS parallel to BC. RS parallel to BC. And the reason is corresponding angles are equal. And now we can use our proportionality theorem. We can say AR over AB is equal to AS over AC. But we know that we have AR equal to DE and AS equal to DF, and that was due to construction. So therefore, we can say DE over AB is equal to DF over AC, and our theorem is proven. Okay, so we have DE over AB is equal to DF over AC. Now just let's go through this to give you an idea where the marks might be allocated. Now this theorem is quite an intense one, so there's actually more marks available normally for the amount of work. So they have to be really, really careful where they avoid marks. So the first mark will be at the construction. And then for the congruency, it's correct statement and reason. Okay, so that's the first 2 marks. And then from the congruency, we will get our mark. And we will say, this is crucial because that makes a link. And then angle our final answer. Okay. And the corresponding angles, the parallel lines, will give us a final mark as well, or give us a mark. And then we get it from there. You can see there's no marks allocated from there because once you've done all the bits up here, the rest just flows through. So I trust this was very helpful to you.